In Lesson 7.6, you'll learn how to identify the possible rational zeros of a polynomial function and find all the rational zeros of a polynomial function. How can the rational zeros theorem solve problems involving large numbers? On an airplane, carry-on baggage must fit into an overhead compartment above the passenger seat. The length of the compartment is 8 inches longer than the height, and the width is 5 inches shorter than the height. The volume of the compartment is 2,772 cubic inches. You can solve the polynomial equation h times h plus 8 times h minus 5 equals 2,772, where h is the height, h plus 8 is the length, and h minus 5 is the width, to find the dimensions of the overhead compartment in which your luggage must fit. Usually it's not practical to test all the possible zeros of a polynomial function using only synthetic substitution. The rational zero theorem can help you choose some possible zeros to test. So if we have a polynomial function with integral coefficients, if p over q is a rational number in simplest form and is a zero of f of x, then p is a factor of the constant and q is a factor of the lead coefficient. So for example, if we have 2x cubed plus 3x squared minus 17x plus 12, if 3 halves is a 0, then 3 is a factor of 12 and 2 is a factor of 2. In addition, if the coefficient of the x term with the highest degree is 1, then we have the following corollary, which is better yet. If the coefficients of a polynomial function are integers such that a sub 0 equals 1 and a sub n does not equal 0, any rational zeros of the function must be factors of a sub n, which is the constant. List all the possible rational zeros of 3x to the fourth minus x cubed plus 4. So we want all the factors of 4, so 4, 2, 1, and they can be positive or negative, over all the factors of 3, well, that's a short list. So we could have 1 divided by 4, or sorry, 4 divided by 1, or 4 divided by 3, 2 divided by 1, or 2 divided by 3, and 1 divided by 1, or 1 divided by 3. And all of these, of course, could be plus or minus. So it's better when the lead coefficient is 1, because then all we have is factors of 15 over factors of 1, which is 1. So we don't even need that part. We could just do the factors of 15. And so the factors of 15 are just 15 of course, 5, 3, and 1, and they could all be positive or negative. The volume of the rectangular solid is 1,120 cubic feet. The width is 2 feet less than the height, and the length is 4 feet more than the height. Find the dimensions of the solid. Anytime you can draw a picture, it's a good idea to draw a picture. They let x represent the height, so x minus 2 would be the width, and x plus 4 would be the length. And of course, we know volume of a rectangular prism is length times width times height, and we get to FOIL it out. So we get v equals x cubed plus 2x squared minus 8x. And in the problem, they told us that the volume was 1,200. Okay, lead coefficient is 1, so all we have to do is check factors of 1,120. We just got this short little list of possible factors, ha ha ha. By Descartes' rule of signs, we know there's exactly one positive real root, so we can make a table and start testing or use your calculator. And the first one that worked was 10. So all of that to say, we found our one positive zero, which you could have found very quickly on your calculator, at 10. So if x is 10, then x minus 2 is 8, and x plus 4 is 14. Find all the zeros of, okay, so we know we need just factors of 30 to check out. And that's a much shorter, more manageable list than the last one. And this table shows the bottom row of them doing synthetic division. Your calculator will do just fine as well. And we find we have a 0 at 2. Now the problem with the calculator is it won't give you a depressed polynomial. You'll know where your 0 is and what works. So if you put 3 into that depressed polynomial, we get a 0 as well. So if we put in 3 into that depressed polynomial we ended up with here, we've got 1, 3, 6, 18, 5, and 15. And what do you know? We get a 0. So now I need factors of 5 that give me a sum of 6, which is 5 and 1. So that'll give us zeros at -5 and -1, and we already had zeros at 3 and 2, so there's our complete list. In summary, you can use the rational zero theorem to find possible zeros of a polynomial function, the integral zero theorem if the coefficients of a polynomial function are integers, such that a sub 0 equals 1, so your lead coefficient is 1, and your constant's not 0, then any rational zeros of the function must be factors of the constant.